Hi, I am Dr. Shyam Sarkar. Welcome to my class. Today we will solve one problem from crystallography. You can see this problem. For a simple cubic crystal, X-ray diffraction shows intense reflections for angles theta 1 and theta 2, which are assigned to 101 and 111 planes respectively. The ratio sin theta 1 by sin theta 2 is, so here four options given: 1.5, 1.22, 0.82, 0.67, and this question was asked in CSIR NET 2015 December. Okay, so once you see this type of problem, automatically in your mind one thing will come, that is Bragg's equation. And you know that Bragg's equation is n lambda equal to 2d sin theta, where n is the order of diffraction, lambda wavelength of X-ray radiation, and d is the interplanar distance, and theta is the angle of diffraction. So from this you will think, so how to determine d values, because d value you will need to solve this problem, and here d will be the different for different crystal system. Since here the crystal system is given simple cubic, so you will get the d value for simple cubic system by this equation: d equal to a by root over of h square plus k square plus l square, where h, k, l are the Miller indices of a plane. That is, if you write down together, HKL represents a plane. Okay, so now let us see how to solve this question. So just now I have shown that n lambda equal to 2d sin theta, and I said n and lambda will not be changed because here the X-ray diffraction is given for a same crystal, only two diffraction angles are given. So you can write down n lambda equal to 2d1 sin theta 1, and n lambda is also equal to 2d2 sin theta 2. Here d1 and d2, because interplanar distance d will be changed with respect to theta. So we consider here for theta 1 the interplanar distance is d1, and for theta 2 interplanar distance is d2. Now if you equate these two equations, you will get d1 sin theta 1 equal to d2 sin theta 2. Therefore if you calculate the ratio, that is sin theta 1 by sin theta 2 will be d2 by d1. Now see, you have to calculate the d2 and d1 value. So d1 d2 how to calculate? So d1 will be equal to the a by root over of h1 square plus k1 square plus l1 square, and similarly d2 will be equal to the a by root over of h2 square plus k2 square plus l2 square. Here a will be the same because the crystal is same, that is simple cubic crystal, and for same crystal two diffraction angles are given. Now come to this previous equation, that is sin theta 1 by sin theta 2. So if you put the value of d1 and d2 here, you will get sin theta 1 by sin theta 2 equal to a by root over of h2 square plus k2 square plus l2 square into root over of h1 square plus k1 square plus l1 square by a. So a will be cancelled since they are same. Now sin theta 1 by sin theta 2 becomes root over of 1 square plus 0 square plus 1 square. Since we have given the h1 k1 l1 value is 101 and h2 k2 l2 is 111. So if you put these values, so it will become root 2 by root 3, and you know the value of root 2 is 1.414, and above for root 3 is 1.732. So if you calculate this ratio 1.414 by 1.732, so after simplification you will get it is around 0.8. So around 0.8 means, see, it is matching with the option C, that is 0.82. Option C will be the correct answer. So in this way you can solve this type of problem. So this is very simple, nothing to worry about it. So if you have any doubt or any further query, you can put your queries in the comment box. I will try to solve in my next video. Okay, so thank you so much for watching this video, and please subscribe this channel for more updates.